Assalamu alaikum. I'm here from the Technical University of Berlin. Today I will present together with my colleague Bernd Muschat. As I said, afterwards a little bit about maintenance overview, maintenance strategies, and especially from our university, the KAP project, Knowledge Awareness Prediction. Something about the Technical University. So we are the largest technical university in Germany with approximately 30,000 students. We have a wide range of subjects and we have the highest rate of foreign students in German universities, which is approximately 20%. This is where we are in Berlin. This is where I work. It's PTZ, Production Technology Center. At the evening, it's pretty nice, and here you can see our test field that we have there in Berlin, where we have our robots, machines, gadgets, and so on. Yes, here in very short, our biggest project that we have in our department is the CRC 1026. It's called Sustainable Manufacturing, Shaping Global Value Creation. The first funding was in 2012, and we will receive until 2015 more than 10 million euros. And hopefully, if we get the full 12 years for the CRC, it will be even more than 30 million that we receive for this project on sustainable manufacturing. And it's, yes, the division of research is across all, at least for us, relevant disciplines. So yes, what's about, just in very short words, because it might be interesting for some of you. What we want to do is we want to bridge the gap between, on the one side, settled markets, and on the other side, hungry markets in the world. So right now, we are living, we could say, we use so much energy that we would need 1.5 worlds to be sustainable. And in 2050, it's approximated that it will be 2.5 worlds that we need. So if we want to enable the hungry markets to have yes, the same possibilities as in the settled markets, we need to design and manufacture products and services in the way that's sustainable. And we also need to change existing process paradigms that we have. Yes, I hope that some of you know this guy. This Dr. Sadiq Abdelal. He's one of my colleagues. Actually, right now, he is turning back to Gaza because he already got his PhD now. And I want to just say a few words about the GCSM that we have in September. That would be in the organizing team are Dr. Abdelal and me. And the deadline for full paper submission, once more, is the 12th of May, whoever is interested. Yes, it's a conference for academics, researchers, and practitioners on the field of sustainable manufacturing. And we offer keynote speeches, panel discussions, parallel sessions, and a global student competition on sustainable sanitation systems. So now about maintenance. Yes, the importance of maintenance, we already talked about that, and especially about availability. So, but what I can add is that about 255 billion euro has been spent in Germany for maintenance in 2009. Yes, another slide that we have not seen right now is that the overall availability of is right now on 70%. In production systems, at least in 2006, and it was considered as usual, and 80% can be evaluated as excellent. So what means 70%? We can see that 70% availability means, on the other side, that we have 110 days where the machines are not running. Even if we reach 99%, which sounds pretty high, would still be almost 4 days where our machines are not running and we cannot produce. So we can see that it's a good aim to try to get as low as possible in this table. Yes, very short historical view on maintenance approaches. We already got 2 slides about that. Yes, I can add that it went from repair to service inspection, and today with TPM improvement. We went from corrective maintenance to preventive maintenance, predictive maintenance, and now so-called aggressive maintenance, which means that we want to improve ourselves, yes, in the context of, for example, TPM. This is another slide. We also didn't have that yet. On the left side, you can see an excellent Porsche. Maybe it's the wrong picture. Opel Corsa would be a little bit better because we would maintain it more. So we see that the repair cost would be very high because we are driving normally a car until there's a breakdown. So we would have high repair costs, and on the other side, very low maintenance costs because we don't maintain it. On the other side, we have the airplane, the Airbus 380, where we would have very high maintenance costs, but pretty low repair costs, because we don't want to wait until there is a breakdown in an airplane. Would be a very bad strategy. In the middle, we see a factory where we have the minimal costs in this, at least in the slide. We can see, yes, on the one side, we still have some maintenance costs, but also repair costs. It would be, yes, cost effective, while only defective parts will be replaced. Yes, this is also a slide we have seen already, more or less. So we have on the one side after failure, on the other side before failure. It's of course wise to be on the before failure side, so on the preventive maintenance, which is can be divided into planned maintenance, condition-based maintenance, and prognostic maintenance. Yes, one maintenance strategy is driving until braking, as I already talked about the Opel Corsa. This is maybe not the best strategy that we can use in factories. So what we want is preventive maintenance. So before the failure, to prevent a breakdown. Yes, what we already talked about is also condition monitoring of machines, or condition-based maintenance. Yeah, the aim is to identify when the system will break, and it offers targeted monitoring and information collection. So we have on the one side continuous monitoring, what would be the monitoring of the machine during all the time, and on the other side the scheduled monitoring. There are pros and cons for both strategies. On the continuous monitoring, it's a protection against fatal damage, and we can use it if we have just a very short reaction time. Then the continuous monitoring would be the better idea. On the other side, we have the scheduled monitoring, yes, where we would maintain at least check in regular intervals. Yes, the motivation for condition monitoring, this is also something we heard. So we would have no unforeseen failures, at least hopefully no unforeseen failures. And we would gain knowledge about relationships between process data to identify and predict failures. So what kind of physical parameters do we have for condition monitoring? We could have the voltage, humidity, temperature, pressure. It just depends on the machine. So yes, right now in some machines we already have parameters for that. We can measure it, but we can still add some more control units to that. Yes, here is one example that we have. It's a damper here on the picture, and we have a strain gauge sensor which is measuring the deform forces. So now if we can see in the damper to run it, then we know it's a case of maintenance now. We also have another example here. It's a wind turbine. It's again the bearing, what we already heard about. So it's pretty difficult to always be next to the wind turbine, especially if it's on the sea. So one possibility is there also to monitor it there and through a cloud shared information. Here is also a strain gauge sensor integrated and a cloud share information system. Yes, on this slide we have another example. It's a cutter module here where we have the blades. Yes, here it's nice to see. So the black one would be the regular forces that are needed, and right now we would be on the red ones. So we would know that something might be wrong with the blades. For example, they got blunt, and yes, we can just see that by the forces that are needed for cutting. And here on the picture you can see the diagnostic unit. This is our project at our university. It's KAP, Knowledge Awareness Prediction. Yes, it's about using the knowledge of the past, awareness of the present, and the prediction of the future. By that, we want to gain more transparency within this project and optimizing production by efficiently using data generated by machines and sensors. And as you can see, we have also some industry partners for this project. Actually, right now I would like to show you a very short video from SAP because they just have the nicest video on this topic, and you can also watch it in whole on YouTube if you like. So I will skip some parts. So as I said, it's about knowledge, awareness and prediction. They're a partner of us, and it's about introducing high performance data streaming processing for real-time decision support. Yes, and the key challenges that we have within this project is to avoid unscheduled downtime and reduce scrap and consumables. So mainly what they are doing in this, or what they are showing in this video, is a production site of Nissan, where they have a production line with AGVs, what are automated guided vehicles. And it's about, yes, that we can see the Nissan factory and the test track in very short and very small. And yes, here you can see the AGVs driving, the automated guided vehicles. And the project is also about the batteries, right now how much energy they have. Here now, any second, yes, right now. Yeah, there you can see the AGVs driving in the factory. And what they are also screening is the, as I said, the battery within these AGVs. So after it gets until a certain point, let's say 10 or 20% of the energy, they will know it in advance. So they know, okay, when they get close to the maintain station, they can stop there, take out the battery, put in the new battery and recharge it. Yes, this is what the one part what they did here at with SAP. And yes, now I would ask my colleague Bernd Muschert to continue.